Okay, guys, I'm here to explain to you or try to explain a little bit better of the notes that I left for your transformation section. If you look at the top of your notes, you have those three basic graphs: linear, quadratic, and absolute value. Okay, so one of them starts out like this, okay? F of x equals x. Well, that's the same as y equals x, which we know is in y equals mx plus b form, or we know that that should be a line. So our general form says that if we were to graph y equals x, it begins at 0, and it would move up 1 over 1. Okay, now on my graphs that I showed you, I went up 1 over 1, and then I went down 1 over 1 as well. So anytime you have your first one starting out with f of x equals x, this is your basic graph. This is where you will start. Okay, then here are your transformations, and you're going to do each one separately. So I'm going to do mine in colors. So if I can get a color here. And I don't have as good a setup as I do at school, so you're going to have to bear with me here. Okay, so I'm going to use red for this first transformation. Now notice, we still have f of x equals x there. Okay, so we still have this graph. But then we're asking ourselves, okay, what is happening to that? It's adding 2. Now, on your notes, it shows that if you have parentheses around the x, and then you put a number in there, you're moving it left or right. If the number is just out to the side with no parentheses, then you're moving it up or down. So in this case, this tells us we're moving all of our points up 2. So remember, this is our general graph. So we're starting with this every time. And now we're taking all 3 of these points and we're going to move them up 2 spots. So here was one of my points. I'm going to move him up 2. I'm going to move this guy up 2. And I'm going to move this guy up 2. There's y equals x plus 2. Now, I know Mrs. Eichenberg was talking about yesterday that you could have just graphed this line. Well, yeah, think about that. F of x we know is the same as y, so we have y equals x plus 2. Where would you begin? You would begin at 2 on the y-axis, and then you would move up 1 over 1, up 1 over 1, and it would continue on that red line. Yeah, you could do that, all right, but you could also say that you know this graph, because you're talking about the transformation. That's the point of this. You could say that you know this graph shifts up 2. So you've showed it and you've described it. Okay? Okay, so now when we start with this last one here, we're still going to go back from the pencil, those 3 original points, because notice we have a y equals x. It's just that now that we have negative 2x. So now we have to think, okay, what does the negative do? And what does the 2 do to our original graph, which was just x? Well, the negative, if we look at our notes, again, it's not in parentheses. It's outside of x. X is not in parentheses with a negative. So it says it reflects over the x-axis. Okay, that means it's going to flip. So every point is going to be opposite up or down than what it was. Okay, so we know it's going to reflect over the x-axis. That takes care of the negative. Okay, then I have to take care of the 2. Well, it says to multiply all of our y coordinates by 2. Remember, our first original points were -1, 0, 0, and 1, 1. So now we're taking these y coordinates. We're ignoring this guy because we're going to take 2 times y. So now we have, if we take 2 times all of our y's, we have -2, 0, and 2. So we are totally ignoring this and thinking, okay, now all of my y coordinates are at those ordered pairs. Okay? All right? So now remember, though, we've got to do 2 things here, so this makes it a little tricky. We have to, yes, go to -1, -2, but we also have to reflect that x-axis. So let me put some more points in here. So here's -1, -2. But then remember, I have to flip this over the x-axis. So if I was at -1, -2, if I flipped it it would be -1, +2. And then this one's supposed to be at 0, 0. Okay, well, if I flip that over the x-axis, there's nothing to flip there. That stays the same. And then my last one, 1, 2. Okay, so I'm here at 1, 2. I'm supposed to flip that, like mirror it over the x-axis. So now I'm down here at 1, -2. And there's my graph. Okay. All right, so there's 3 examples using linear. Now, let's try one with quadratic. Just a second, guys. Okay, I'm back. All right, so next one, f of x equals x squared. Okay, we know this looks like a parabola, but what would my basic points be? All right, your basic points of a parabola are 0, 0, 1, 1, and you could go on. You could say 2, 4, 3, 9, just like our XY table is. But you know these are our 3 basic points. They call that basically like our general graph, okay? So we just did this part. Y equals x squared, or f of x equals x squared, will always look like this. Okay, and you could go through and find the vertex, do your axis of symmetry, do your XY table, but I'm telling you it will be this every time. Okay? All right, so then once you have your general graph, now we go to our first transformation. Now notice, this time we have parentheses. Parentheses inside of our, or with x, I guess you should say. Okay? So what that means is that that has to move either left or right. And remember, it's opposite of what it looks like. And I know that's actually, now I'm second guessing myself. Yeah, I'm sticking with that it moves left 1 because you're subtracting 1. Yeah. I'm going to try to multitask and look that up because I don't have my notes here, but I'm pretty sure that moves left 1. Okay, so again, I have all 3 of these normal points. Okay, I'm going to move all 3 of these points left 1. Just a second, I'm looking something up. Okay. Just chill. I know you're probably thinking, why doesn't Mrs. Holloway know this? Well, because it's 10:22 and I don't. Oh, my goodness gracious, guys. Okay, so guys, if I'm backwards on this, fix it, okay? And I'll look it up after I get off my video and make sure. But okay, I'm saying this moves left 1. So, oops, sorry, shifts left 1. So all of my points are going to move left 1. And there's my new graph. Okay, now I noticed when I started that one that I didn't finish my description here. Okay, yes, it reflects the x-axis, but since it multiplied by 2, it actually shrinks. Okay, by a multiple of 2. Okay, and again, check with Mrs. Poor on my language of how I wrote that on my example. Okay, all right. Okay, so again, the difference up here, that plus 2 was not in parentheses, so it could not move that graph left or right. But here, it is in parentheses, so it moves my points left or right. Okay, now let's go to this next one. All right, and I'm going to add something on here. Let's add plus 1. Okay, all right, so now we see a negative inside the parentheses. That means that reflects the y-axis. Okay, so we definitely know it reflects y-axis. And then this minus 1 is going to mean it also goes down 1 because he's not in parentheses. So he can't be a shift like this. All right, so now, and I can do these steps all at once. So from my green, okay, it says I'm supposed to reflect the y-axis. Here's my y-axis right here. Well, if I flip that, I can't flip over the y-axis. He's going to stay right there and go down 1. Okay. Then my next one says I'm going to flip it over the y-axis, reflecting it. It would move over here and then down 1. And then I'm going to do the same thing here. Reflect it over the y-axis and move it down 1. And there's my final graph. Okay? So that should help you a little bit on your shifts, your reflections, your shrinks. Okay? That can at least help you with that in-class worksheet. And like I said, I'm going to double check and make sure that I shifted the right direction. Hey guys, I went back and checked and I was wrong on this one here. Okay, this should be shifts right 1. So ignore my red, okay? Ignore my red. All those points should have gone right 1. And there would have been my new parabola. Sorry about that. So always remember with your left and right shifts, they're opposite of what it looked like. That looked like left 1, but it should be right 1, and vice versa. If it would have been plus 1, you would have moved left. But when it's outside the parentheses, like up here or down here, it looks, you do exactly like it looks. You go up 2, you go down 1. But if it's inside parentheses, you have to think backwards. Minus 1 would be right 1. Plus 1 would be left 1.